All right. Well, I don't know how much of that you guys actually heard from behind the scenes. It was getting a little uncomfortable here for Takeo After Dark, but hey, what happens at Takeo After Dark stays at Takeo After Dark. That's the only thing I can tell you. Good evening, everybody, and welcome to what is this, number 4 or number 5, Dave? I can't remember.
Session four.
Session 4. This is session 4. I'm John Barba, joined by Dave Holdorf, aka Ogie Ogletarp, from the movie Slapshot, which is our theme tonight. In the background, we don't have them up on camera because they're feeling shy all of a sudden. I have Tim Ward and John Messenbrink from our Hosts Mechanical Hub. Gentlemen, say hello.
We have radio voices, John. Radio.
Yeah,
Yes,
we do have radio voices.
we have a voice for face for radio and a voice
Hanson
for
brothers from
velvet.
far away.
Oh yeah, face for radio. I'm sorry. Yeah.
There you go. There you go. And our special guest lecturer tonight is Kevin Shea from Emerson Swan, the TACO rep in the Northeast in New England. And Kevin is going to talk to us a little bit about all the wonders of combustion analysis, the fine art and subtle science of combustion analysis. So make sure if you got some questions on that, it's really it's the thing that puts all this on paper. It makes everything sing and dance. So you know that you have safe and efficient combustion and everything's tuned properly. And it's just important. There's no two ways about it. More important than it's ever been. Anyway, so why don't we dispense with the how do you do's, and we'll just get this show on the road. So yeah, we are in session number 4 of TACO After Dark, and in episode 4, we're going to talk about zoning and circulator selection for our sample project, which should take about 20 minutes to a half hour. Then we'll turn it over to Kevin for discussion on combustion analysis. Now, just a real quick overview about navigating the control panel. Okay, everybody who's been here, you guys know how to do it. If this is your first time, work with me here. You should see that little orange arrow. All right, the little orange arrow on your screen right there. If it's pointing to the left, you want to click on it and expand your control panel, and it'll give you some things to do. All right. So that'll expand it. And once you expand it, way down at the bottom, you're going to see the area where you're going to ask questions. So I know a lot of you have already done that. So if you can do that, a lot of you have already done that. The rest of you who have not, if you could just type in a hi, hello, how are you? And good, we got some greetings and salutations. Very good. Okay, Reg Dunlop, player coach. Very good, Mr. Trotta. All right, excellent. Jason's with us. Dan Cook, again, with us yet again. Welcome, Dan. Thanks for being with us. All right. Excellent. Good. So everybody kind of gets an idea how to do that. And your questions, Mr. Shaw, Chuck Shaw, glad to have you with us. Jason Mangos, excellent. Very good. Very good. So guys, just as we go through this, just type in your questions as they come up, and we'll do our best to answer each and every one of them. We'll stay on as long as we need to answer all of your questions, and we'll have some fun while we're doing it too. All righty. So let's get this show on the road. Now, Dave, Kevin, and I really aren't quite the Hanson brothers, or the Handsome brothers for that matter. But tonight, Caddyshack is our movie theme, and our trivia question will be focused on the movie Caddyshack. What am I doing here?
I don't know, man.
What am I doing?
I was going to say I'm in the wrong set.
Yeah, I know. Not Caddyshack. It is Slapshot. Slapshot, which is basically Caddyshack on ice, if you will. So let's talk about our job. Let's enough of this. Let's get down to work here, shall we? Now, you guys all remember we've been doing this project since we started, and we did the heat loss. We did a room by room heat loss, and we walked through that. Then last couple of times we talked about putting different types of heat in there, whether it was radiant heat or fin tube baseboard panel radiators, that kind of stuff. We looked at all those different options. And today we're going to just start putting all this together and figuring out what we're going to do for a circulator and for zoning. All right, we're looking at 3 zones here. That's kind of the way I did it. We had anywhere from 3 zones to 7 zones for when we asked earlier. We're going to go with 3 zones here. The basement is going to be a zone. The family room, kitchen, dining, living entry is going to be a zone. And then the 3 bedrooms and 2 baths will be a 3rd zone. So we're going to work with 3 zones here. So that's kind of where we're going to go. And these are the sizes of the 3 zones. The total load for the house, if you'll recall, when we did the heat loss analysis, the total load for the house was 30,577 BTUs. It was not a big shack, okay? Even though it's like 2,200 square feet. It was one floor above ground, one floor being the basement. Not a big heat loss area, even though it's located in Norwich, Connecticut, and we designed to a 7-degree outdoor design temperature. And it wasn't a ridiculously well insulated house either. It was just normal, regular construction, which kind of tells you a little something about heat loss. So we actually did this heat loss analysis and we came up with 30,577 BTUs. We'll talk about boiler selection maybe next week a little bit, but suffice it to say, we're not going to find a boiler that small. All right, we're going to be finding a boiler bigger than this, and the question is just how much bigger. We're going to do the very best we can. So here's our total load of 30,577, and it's broken down by zone. Zone 1, 12,116 BTUs. Zone 2, the bedrooms, 8,275, and the basements, 10,186 BTUs. Alrighty, let's take a quick look at zone 1 in the particulars. All right, there's all of our pieces of radiation, and the total load is 12,116. So we got to find the flow rate. And to find the flow rate, we're going to divide the BTU load, 12,116, by the product of delta T times 500. Okay, that's the universal hydronics formula. We've beaten you over the head with that through 2 different Takeo After Dark sessions. I hope we understand how important that formula is. It's the universal hydronics formula. So GPM, your flow rate, the gallons per minute flow rate you need to satisfy the heating load of a zone, in this case, is equal to the BTUH load of that zone divided by your designed for delta T, or the temperature drop of the fluid as it goes through the system, times 500. Now 500, of course, is that mathematical constant that we use with 100% water. It comes from multiplying the weight of 1 gallon of water, 8.33 pounds, times the number of minutes in an hour, 60, times the specific gravity of the fluid, that's 1, times the specific heat of the fluid, that's also 1. So 8.33 times 60 times 1 is 499.8. Hey, I'll call that 500 if you will. All right. So that's where we come up with 10,000. It just makes the math easy. All right. It just makes the math easy. So we do our math, 12,116 divided by 10,000. We're looking at about 1.2 gallons per minute of flow. That ain't a lot of flow. That's a very small amount of flow, 1.2 GPM for that zone. All right, so we know that's the flow rate. Now to size a circulator for that zone, we have to figure out the head loss of that zone. So again, we got to figure out where we're going to stick our boiler. If you take a look at that picture right there, there's the flue right next to the linen closet, and we're just going to go regular old boiler here. We're not going to get crazy or anything. So that regular old boiler is going to be down there in the basement, and right underneath that it's where we're going to put the boiler. Okay, so there's your flue pipe, and there's the boiler right down there in the basement. So we can kind of estimate from this point how much pipe we're going to be running through all of those zones. So we can take a look at it like this, okay? There's our basic zone for that first floor. So we've got 8 feet, we've got another 10 feet, we got 20 feet there, 6 feet there, 16 feet there, and so on and so on and so on until we go back down to the boiler. And that's just, we can measure that on the plans. If we were doing the installation, we'd measure the pipe as we did it, or we'd take our very best educated guess as to how long that run would be. So we go through our additions here. Now I got our entire first floor run of just pipe is 102 feet. The element in the baseboard, 25 feet. The up downs, we're going up, we're going down, we're going up, we're going down, we're going up, we're going down, is about 20 feet. And then the up down for the boiler might be another 12 feet. Total run, we'll call it about 159, 160 feet total from the gazouta side of the circulator all the way back to the gazinda side of the circulator. So that's our total run. Now, if we were to estimate the head loss, this is your Friday afternoon, 5 o'clock, I got to get something down here, estimation. We would estimate our run, in this case, 159 feet, and then we'd multiply it by 1.5. That's going to allow for valves and fittings and stuff that's in the way, right? Fittings have the same pressure drop as pipe. A 3/4 inch copper elbow has the same pressure drop as 2.5 feet of straight copper pipe. 45 has the same pressure drop as 1 foot of pipe. A T has the same pressure drop as 5 foot of pipe, et cetera, et cetera. We can't count them. We're going to allow for them. And we're going to basically add 50% to the length to allow for those fittings. So 159 times 1.5. And then to estimate the head, we'll simply continue multiplying, and we're going to multiply by 0.04. 0.04 represents 4 feet of head loss for every 100 feet of straight, properly sized pipe at the maximum flow rate for that size of pipe. You got to remember that part, guys. So 0.04 represents 4 feet of head for every 100 feet of straight, properly sized pipe at the maximum flow rate for that size of pipe. So in this example, we're kind of estimating the head loss. If it's 3/4 inch pipe, we're estimating the head loss as if the flow rate were 4 gallons a minute. But we know the flow rate really only needs to be 1.1 or 1.2 gallons per minute. So using this formula, we're going to wicked overestimate the head. I mean, it's going to be way, way, way bigger than it really is. In this example, we're talking about 9.5 feet ahead. So if we wanted a circulator just for that one zone, it would need to do 1.2 gallons a minute at 9.5 feet ahead. Your 007 is going to handle that with no problems whatsoever. All right. But we also got to understand that's way more pump than we need. It's way more pump than we need. How much more pump? I'm going to show you how much more pump. This is, you've seen this, if you've been through these sessions before, you've seen this chart before. This comes from the Copper Development Association's Copper Tube Handbook. And it's a mind-numbingly dull book, but this one chart is pretty cool because it gives you the pressure loss of water due to friction in types K, L, and M copper, and it gives it to you in PSI per linear foot. So this is the pressure drop in PSI. When we deal with pressure drop in our piping systems, we talk about feet of head. We have to convert PSI to feet of head, and we do that by multiplying whatever the PSI is by 2.31. 2.31. Now, what that means is that comes from basics of day one of plumbing school. I don't know if you guys went over this in plumbing school. A column of water 28 inches high or 2.31 feet high will have a gauge pressure at the bottom of 1 PSI. Doesn't matter how big around it is, just how high it is. 28 inches or 2.31 feet high. Now, the engineers will talk about PSI in terms of pressure drop. We deal in feet of head. All right, so whatever the PSI is, we multiply it by 2.31. That's the feet of head loss that we're talking about. All right, it's got nothing to do with the height. It's got nothing to do with how high the building is. It's just how we express pressure drop on our end of the business. So yeah, that's kind of where we're at. So let's presume if you were doing copper fin tube baseboard, chances are you've got 3/4 inch element, and your default is to go to 3/4 inch pipe, right? 3/4 inch pipe at 1 gallon a minute, 3/4 inch pipe. My pressure drop through 3/4 inch type M copper is 0.001 PSI per foot of pipe, or 1/1000th of a PSI per foot. All right, that's not a lot of head loss, 0.001 PSI per foot. So let's math this out again here. 159 feet times 1.5, because we got to allow for the fittings, all right? That's going to give us 239 feet. Now let's multiply 239 times 0.001, all right? That's going to give us 0.239 PSI. That's the pressure drop, 0.239 PSI. So to turn that into feet ahead, we're going to multiply by 2.31, all right? And we're dealing with 0.6 of a foot ahead. That's not much, okay? You could just get an aggressive hamster running through one of those exercise wheels, and that'll give you enough to pump 1.1 gallon a minute through that pipe. That's 0.6 of a foot ahead. Do you remember how we estimated? We came up with 9.5. All right, there's the difference. Now, I remember I said earlier you had to do the default's 3/4 inch copper, right? But 1.2 gallons a minute kind of fits in the wheelhouse of something else. I want to show of hands here. Just what would you guys say to using 1/2 inch pipe for this zone? Let me know what you want, what you think. Type something in. I'd like to hear what you guys have to say. Would you use 1/2 inch pipe for this zone? forget about the element for a minute, because you can't, they make 1/2-inch element, but you can't find it. You could, but you can't find it, you know. But would you use 1/2-inch pipe, maybe even 1/2-inch PEX, all right? But just talk about 1/2-inch copper. Why wouldn't you? All right, it's less expensive, it's easier to work with, it's got the carrying capacity for this zone. Let's see what happens if we were to use 1/2-inch pipe here instead of 3/4. All right, so 1/2-inch pipe, our pressure drop per foot of pipe goes up some. It's 0.007 psi per foot of pipe. So now 239 times 0.007, or 007 if you will, psi per foot of pipe, gives you a pressure loss of 1.7 psi. Let's multiply that by 2.31. Now we're dealing with 4 feet ahead. There's no reason other than I just can't do it to not use 1/2-inch pipe here, right? There's no reason not to. All right, so you're 4 feet ahead, and you're doing just fine. And you're gonna make that. It's going to give us a lot more to work with in terms of a circulator. Does this make sense, y'all? Let me. Is this working for you? Let me know if this makes sense. I'm going to check the questions here.
Yeah, some people said sure, why not? But then George had mentioned it might look weird, but I'm like, to who?
Well, yeah, that's right.
I mean, it might look, because we're used to working, and I can understand where he's coming from because we're used to working with 3/4. But that's why we're hired by the homeowners to do this stuff, right?
That's right.
We're supposed to be the expert at this. So, hey, that's what it's going to do. That's what we need. We don't need the 3/4. So, what does look weird is just because of what we're used to. So, yeah, I hear you.
Bill Chanel asked about why the big difference from the estimate to the calculated feet ahead. Well, remember when we said the estimate was based upon the maximum flow rate for that size of pipe, all right? We at 3/4 inch, we estimated, we did the math and we presumed that the head is based upon 4 feet ahead for every 100 feet of straight properly sized pipe. That's based upon 4 gallons a minute flow, the maximum flow rate through that 3/4 inch pipe. When we went back and did it and mathed it out, it was considerably lower because this chart's based on flow rate. The quick method is based on, well, I'm going to presume the flow rate's 4 gallons a minute and we're going to work off that. It's a shortcut. It's very easy. It'll never get you into trouble other than over pumping. You'll never undersize a pump that way. So that's kind of that's always interesting. When you actually math it out, when flow goes up, head goes up exponentially. All right, it's kind of a function of the square of the increase. So it's not a linear. So it's like 2 gallons a minute. I got 2 feet ahead. So at 4 gallons a minute, I should have 4 feet ahead. No, it goes up. It shoots up kind of like a rocket ship like that. So that's kind of an interesting phenomenon when it comes to flow and to head loss.
And even this is estimated on the high side too, because you added the 1.5 in there instead of going through fitting by fitting of what the pressure drop is there too. So this is also giving us probably a little bump. So you can still be safe with this. Still be safe with what we put up here on the screen because it still has a little bit of fudge thrown in.
Yeah, and plus whatever fudge is actually in the heat loss as well. Even though it only came out to 30,000, I'll bet you there's a handful of fudge right in there too. So very good. All right, we got some questions and some comments coming in here. Can you back into a maximum run length for 1/2-inch copper, maybe based on two gauge experiences? Can you rephrase that, Mike? Can you back into the maximum run length? The maximum,
well,
I think the maximum.
Yeah, what would you do for a 1/2-inch pipe? If you had a 1/2-inch loop, what would be your longest loop that you have connected to it? I usually say, 25,000 BTUs, 2.5 gallons a minute. You're going to run in about a 1/2-inch and, you're going to keep it shorter, about 50 feet. You can go a little bit long. Actually, no, I'm sorry. Look at the numbers here, so there's way too many. Yeah, I usually max out about 25,000 BTUs on 1/2-inch pipe and 1/2-inch element.
Yeah. So we got, there's some other comments here. Like, I've always figured, 3/4 inch, once you got into 2 gallons a minute or more, you're probably looking at 3/4 inch pipe, and basically up to 2 gallons a minute or up to 20,000 BTUs, you could certainly do 1/2 inch pipe. And PEX is going to make this a little bit more interesting, because now PEX, 1/2 inch PEX, 1/2 inch copper, 1/2 inch PEX has a higher per foot pressure loss than 1/2 inch copper because of the smaller ID. However, there's no fittings. So it kind of balances out a little bit. In this case, if it were me, this job is screaming for 1/2 inch PEX, in my opinion, but that's kind of how I would do it anyway.
And even a manifold style too, if you want to really take advantage of it. So
yeah,
I mean,
absolutely.
we're showing, probably putting all the rooms together on the same zone here, on the same loop. But if you had some 1/2 inch PEX laying around, get yourself a 3-loop manifold and do a loop to each room. Still make it one zone.
You could,
right?
mm-hmm.
Still leave it as one zone if you wanted it to. Depends on how you want to work it out. But if you've got a manifold there, you have the option to make it 3 zones later, or at least try to control some of the flow depending on the manifold that you use.
Yeah, I mean, there's all kinds of different things you could do here. You could do a series loop with PEX. You could do a home run. I mean, you've got a lot of options here as well. Some interesting question: is minimum velocity a factor? Is minimum velocity? Always is, yeah. We're looking for a minimum velocity of 2 feet per second and a maximum of 4. A maximum of 4 feet per second. And I think in this case, we're not going to have an issue in either case here. If we were to use 3/4 inch PEX, 3/4 inch copper, we'd really be on this one zone. I think we'd probably have a velocity problem in theory, but the minute you put a pump on it, the velocity problem goes away, okay? Because we're not going to pump 1 gallon a minute through that. We can't, okay? It's impossible. Once you put a circulator on it, the circulator takes over. So in theory, we would look at this, well, 1.2 gallons a minute through 3/4 inch pipe, we're going to have a velocity problem. No, we're not, because we're putting a pump on this thing, and the pump's going to take care of that for us. So if you take, so look at it from that standpoint, if that makes sense, John Randall, to you on the velocity question, because that's a really good one. That's a really good one. And head, of course, if we did a home run type of system, absolutely the head would change. Absolutely the head loss would change. But it also gives us the opportunity to use 1/2 inch pipe or even 3/8 inch pipe at this point. I mean, it really gets there's so many options here, man, to when you're dealing with such small loads and such, you could do so many different things to the point where you could get yourself, kind of that paralysis by analysis thing. So let's move on here and look at the rest of the house, okay? Now, zone 2, we're looking at zone 2. In zone 2, we were talking 0.83 GPM, okay? It's 8,275 BTUs. We math that out. That comes up to about 0.83 GPM at a little less than 2 feet ahead, okay? Not much, just about 2 feet ahead. And then if we go to, and again, we're talking 1/2 inch pipe, and if we go to the basement, 10,186 BTUs, that's about 1 gallon a minute. Again, right around 2 feet ahead, depending on how you pipe it up. So what this tells me is we need our system, okay? We're going to need, because right now what's happening is this is kind of screaming zone valves. If I'm looking at this thing, I can't come up with a rationale for putting one circulator on each zone. Can anybody else? Because I mean, this is talking about doing this. That's doing finished carpentry with a sledgehammer. All right. If we've got, I mean, one circulator to do 0.83 GPM at 2 foot ahead, another circulator to do 1 gallon a minute at 2 feet ahead, and a third circulator to do 1.2 GPM at 4 feet ahead, that doesn't make any sense. If anybody feels differently, let me know. But Dave, Ogie or Dave, what do you think?
Oh, I'm a zone valve guy all the way. So, I mean, I just prefer, I know the capacity of these things on the circulator and what it's going to do. So, yeah, that's the way I'm designing.
Yeah. Robert O'Brien says, you guys sell circulators, right? And we also sell zone valves. So we got you going both ways, bro.
We got both. Yep.
We got both. We got both, What is it? Buy all you want. We'll make more. Okay, so here's kind of what we're looking at. So we got 30,577 beaches. That total flow rate's about going to be just over 3 gallons a minute, just over 3 gallons a minute. and I got 4 feet ahead, 2 feet ahead, and 2 feet ahead. Now we know, right? We know head's not cumulative. When we're sizing a circulator for zone valves, we don't add all the head together. So it isn't 4 plus 2 plus 2 equals 8 feet ahead. We just have to overcome the head loss through the worst case zone. If we overcome the head loss through the worst case zone, we can overcome the others. If I can do 4 feet ahead, I sure as heck can do 2 feet ahead. So that's a common mistake people make when sizing circulators. The most common mistake is, well, I got to go up 3 flights of stairs. I need, I need a higher head pump to get all that water all the way up there. No, we don't, because it's up and down doesn't matter. It's a closed loop. The other most common mistake is, well, I add all the head loss together for all of my zones, and then I'm going to need one big honking pump for my zone valve jobs, and it is not necessary. In this case, we're talking 3 gallons a minute, 4 feet ahead. Okay, 3 gallons a minute, 4 feet ahead is what we're going to need. Now let's take a look at, a typical Taco 3-speed circulator, the 0015, the 0015 3-speed, and just pretty much anybody's 3-speed circulator is going to have virtually identical performance curves. They're not, nobody's all that different. All right. And we've got low, medium, and high. We'll put the 0010 off to the side for a moment, because the 0010 is a different cat altogether, even though, it's a circulator and you certainly could use it here, but we're going to focus on the 0015. So let's take a look. Remember, we've talked about in our original session, we talked about system curves and pump curves. And what happens is, once you put a circulator on a system, the system does what the circulator says. The circulator's in charge, man. The circulator's in charge. The system has to work on the pump performance curve. It has no choice. We did a heck of a lot of math to come up with that number, but the minute we slap a pump on it, we're never going to see that. All right, we're just not. Okay, the circulator's going to do what the system's going to do what the circulator tells it to do. So here's my requirement: 3 gallons a minute at 4 feet ahead, right here. 3 gallons a minute at 4 feet ahead. Now, again, we're going to put the 0010 off to the side for a minute. Let's just look at the 0015. Clearly, we're looking at low speed, right? The problem with 3-speed pumps is, what does everybody do with them? Okay, what does everybody do with a 3-speed pump? Dave, what does everybody do with a 3-speed pump?
Put it on high.
Put it on high. Contractor, no callback mode, man. If a little is good, a lot is better. And if a lot is better, everything the damn thing can do has got to be the best. I don't want the phone call, man. So they're going to go right to high, which defeats the purpose of having a 3-speed pump in the first place. But that's my own emotional issue. All right. So let's, sorry, centered, focused, we're good. What we did here is we're figuring out a system curve, and a system curve is a theoretical curve. It's a plot of different points showing the mathematical correlation between flow and head in an individual piping system. There's a mathematical correlation between flow and head, and in this case, 3 gallons a minute, 4 feet ahead. There's a math formula I can use, or I can use a B&G system sizer wheel scale number 5 to figure this out. And I can plot out, I know what the head is at 3 gallons a minute. Well, what would the head be at 4 gallons a minute? What would it be at 5? What would it be at 6, et cetera, et cetera? I figure those points out, put them on the plot, connect the dots, just like we did in 5th grade math that we thought we were wasting our time with. And now I have a system curve. So at 4 gallons a minute, 5 gallons a minute, 6 gallons a minute, I see my system curve, my points on the plot, and then I connect the dots. And voila, there's my system curve. Why is the system curve important? The system curve is important is because the system is not going to work here ever, ever, ever. Every time this system, if I'm using low speed, every time the system comes on with all 3 zones calling, it will be working at just a touch under 4 gallons a minute at about 6.5 feet ahead. Every single time. It'll do that in October, it'll do that in January, it'll do that in April. It's always going to do that. I'm never going to see 3 gallons a minute at 4 feet ahead. It's just not going to happen. The system has to work on the pump curve. If instead I said, hey, I'm going to go to medium because I want to be safe, well, now every time that thing comes on, I'm going to be working at 5 gallons a minute at 11 feet ahead every single time. It's going to do that in October. It's going to do that in January. It's going to do that in April. And if I say the heck with it, I'm going full speed, man. No, no worries here. I'm going to, go to complete contractor, no callback mode. Now I'm at about 5.5 gallons a minute at about 14 feet ahead. I've introduced, not only am I way over pumping the system, but now I've also introduced banging zone valves into the equation at high speed, definitely at medium speed, most likely when the zones are closing. So I've got those issues that I need to deal with. That's again, one of the inherent problems with 3-speed circulators is they're terrible zone valve pumps. They're just terrible zone valve pumps. In this example, if I went with low, I'd be okay. The problem, however, is all zones calling, 4 gallons a minute. I only need 3. I'm getting 33% more flow than I need under design conditions. So what's going to happen is under design conditions, if we go back to that universal hydronics formula, right? GPM equals BTUH divided by delta T times 500. If I go back here, my BTUH is still 30,000, right? But now I'm at 4 gallons a minute and not 3. That 20-degree delta T I designed to, never going to see it. The best I'm ever going to see is 15. So that 33% increase in flow results in a 25% decrease in delta T. So instead of the water going out at 180 and coming back at 160, it's going out at 180, coming back at 165. And the low temperature model, if it's going out at 140, it's coming back at 125. Doesn't sound like a big deal, but we're shrinking that delta T. What, folks, is that going to cause the boiler to do? We all know this. It's going to cause the boiler to short cycle, and it's just going to get worse because it's always going to be at 4 gallons a minute, even if that goes down. All right, even if it will go down at 50% load, that's going to be 15,000 BTUs. I'm still going at 4 gallons a minute. That's going to be at 7.5 degrees. And you can see we've got a boiler that's going to be bigger than it needs to be anyway, right? Because we only need 30,000 BTUs. If it's not a ModCon boiler, it's still going to be bigger than, and even if it is a ModCon boiler, if the turn down ratio doesn't go down that low, that boiler is going to short cycle even more. All right. This is normal hydronics. This is what we do. But this, folks, is where we get our efficiency. We want to make sure we match the flow to the load as best we can. With this application, yeah, you know, we're okay. It's not horrible, but this is as good as it's going to get. All right. I just want to show you the rest of the other zones as we put them in here. All right. So my other zones, if I were to let's go here. Yeah, here's one, my basement zone, 1 gallon a minute at 2 feet ahead. Okay, here's the system curve for that. All right, now again at low speed, you know, we need 1 gallon a minute. I'm going to be giving it 2. So again, my delta T with just that zone calling is not going to be much better than 10 ever. Okay, if I'm at low speed, and if I go way the heck up here, well, now I'm at 3 gallons a minute instead of 1. You can do the math there. With the small bedroom zones, okay, the small bedroom zones, okay, there's that blue dot and the other ones that go with it, okay, you're going to see that we have, okay, we're going to go right up here, and again, it's almost the same type of curve. So again, we have these issues of short cycling. I hope that makes sense to you, because that's just plain old normal. If you use the 0010 here, I swear the 0010 at low speed would be a far better choice than the 0015. I guess the 0010 is going to be a more expensive pump. Okay, it's designed to be a B&G 100 Takeo 110 replacement pump. You know, on the return side of those big old honking boilers, that's what it's designed to do. But in this case, it'd be a better choice. All right, it'd be a much better choice. What about ECM? Okay, let's take a look at the 0015 E3. Again, setting this at low speed, we're at 5 foot ahead. Well, okay, that's not so bad, man. That's actually looking pretty good. 3 gallons a minute, 4 feet ahead. Let's figure the rest of this out. Okay, here's my system curve. So what's really going to happen is I'm going to be working right around here on that 5 foot ahead constant pressure line. So that's a little less than 3.5 gallons a minute. That's better. Okay, that's significantly better than where we were in terms of operation. Are we saving a truckload of watts here as well? Oh, heck yes. We are saving quite a few watts. That might be working at less than 20 watts at that point. Okay, let's put the rest of these in. Here's just the second zone. So we'll be operating probably right around here. And here's that small zone, which means we'll probably be operating right about here. Now, here's the thing here. In this case, how much variable speededness are we getting? We're getting about this much variable speededness. That's about as much variation in speed as we're going to get. So it might go down to maybe 7 watts, up to 18 watts, maybe. I'm just taking a wild guess based on what I know about this pump. So that might be your speed variation. Okay, it's not a lot, but if we get this thing working around 7 watts to 18 watts, that's a heck of a lot better than 50 or 60 or 70 watts. Okay, and that's why you want to make sure that hey, I'm gonna make sure I pick the right pump performance curve by going to that low speed. If I go to medium speed, I'm saving some watts, but I'm still not doing myself much of a favor in terms of the incredible shrinking delta T. And I say, "Oh, the hell with it, I'll just put it on high and walk away and be safe." Well, I've got no variable speed in this whatsoever, and I really haven't. All I'm doing now is I've cut my wattage in about half. That's about it. Okay, not a bad thing, but I'm not. It's like I'm driving I'm buying a Ferrari, but I'm not really driving it like one, if that makes any sense. I can come up with a better analogy though. So what do you guys think? Does that make sense to you, Dave? Does that make sense?
Yeah. Well, it's like having a Volkswagen and you install a V8
I
in
say
it,
Dave.
and all you do is ever go to the corner deli.
There you go.
Yeah.
Okay, that's even better. Okay, that's even better. I like that. Okay. Boom, boom, boom. I've got a couple questions here. If you have all the zone valves open, even then you won't add total head for the pump? No, it's just the worst case zone. It's just the worst case zone, because if I can overcome the head loss of the worst case zone, this is a parallel piping system, right? It's a parallel piping system. And in a parallel piping system, if you overcome the worst case head loss, you can overcome the lower head losses. It's because it's not in series. I don't have the same, I have different water going through the other zones, okay? So I don't have to add everything together. It's not the same water going through going through 4 gallon, the 4 foot ahead zone, then the 2 foot ahead zone, then the other 2 foot ahead zone. That would be head in series. In this case, it's simply head in, it's head in parallel, and in parallel, you don't add it together. I don't know if that helps you. Could you add taco setter balancing valves to control the flow better on these things, on the smaller zones? You certainly could. You certainly could to that end. Again, it'll work. It'll help. It'll just set the maximum flow rate for all that. You still, for design conditions, you'll still be pumping that same flow rate when it gets warmer out with either a fixed speed pump, or in this case a delta P pump. You'd still be getting that. So yeah, you certainly can. You certainly could do that.
I mean, I see you're adding more dollars to a project when you're putting in flow setters, when all that means is the thermostat might shut off a little bit sooner. So I look at thermostats sometimes as circuit setters, So if you really want to control the flow or control the temperature in each space, put a thermostat in it. So and homeowners will like that more because they have more control over the system compared to the stuff downstairs. So that's my thoughts. Keep it simple.
Very good. Robert Dressler, if we were in the same room, I'd give you a big old hug, man. Watts don't really matter to me, but the delta T gets back in line. Worried about the delta T? Absolutely. I think that's the bigger prize here, because the delta, when you start shrinking the delta T on a system, and the delta T is going to shrink with any pump, even a variable speed delta T pump. Once you reach that minimum speed and the load keeps going down, the delta T is going to shrink. The thing is, let's keep the delta T as wide as we can for as much of the heating season as we can and maximize the efficiency, rather than saying, I don't really give a crap about the delta T. We're just going to ram the water the hell through these zones, whether it wants to go or not. So yeah, I get that. The delta T, making that delta T as wide as we can make it to our out to our design level for as much of the heating season as we can, is only going to enhance the overall efficiency and economy of our operation and the lifespan of the heating system. It's just that's advanced hydronics in my book anyway. So very good, very good. Alrighty. And let's so again, that's what we would do with a 3-speed or 3-setting variable speed ECM circulator. So hopefully that helps you. Now, before we turn it over to Kevin, and again, we're gonna go over all these questions here. Boy, oh boy, Kevin, I didn't leave you much time, man. I'm sorry.
That's okay.
We got to talking. We got to talking. Alrighty. So the Takeo movie trivia question of the night. Okay. Now, Slapshot is the work of director George Roy Hill, and it stars Paul Newman as the Charlestown Chiefs player coach Reg Dunlop. This was not the first time George Roy Hill and Paul Newman teamed up. In fact, They teamed up in 2 other instances for 2 other movies. What 2 other films did George Roy Hill direct Paul Newman? All right. What I want you to do is put your answers in the question thing, and when we get to the end of the session, then we're going to cut it off. So you got a few minutes to think about this. But put your answers in here, and we will pick a winner next week for this, and you'll get a marvelous prize package of incredible stuff. So I'm going to apologize in advance to Kevin because I've yacked way too long here. I've taken about 8 minutes of Kevin's time. So Kevin, you feel free to do what you need to do. But we're going to turn it right over to you, and we're going to make the sign of the cross before we go.
But don't rush it.
And I'm going to turn this.
Yeah, we're all hanging out still anyway, so don't rush it. Make sure
Yeah,
everybody
we're
gets
all
what they
hanging.
need
Don't
out of
worry.
this.
Yeah, don't worry, Kevin. We are. It's Wednesday night in the middle of summer, so we're cool. All right. So I'm going to turn this bad boy over to you, Mr. Shea.
Okay. Let's see. Hopefully you should see my screen now.
Looking good.
I do.
Okay.
I do. There you are.
All right. Well, I'm just going to start moving right into this. So, John, thank you for asking me to come out tonight. I appreciate the opportunity, and anytime I can get a chance to help out and work with TACO in the TACO family, it's always certainly my pleasure. So that being said, combustion analysis, I wrote up here, it's not an option. And I'm going to say, you know, by the time we get done with this quick presentation, hopefully you'll agree with me. So the first thing I'm thinking of is when I think of combustion analysis is the first thing I have to do is I have to put that probe into a vent pipe and start taking readings. Well, right off the bat, I can't make the assumption that the vent pipe is proper. I have to make an assessment about the vent, whether it's a chimney or whatever, and know whether or not the venting or the way that the combustion system is moving the air through the combustion process is proper. And that's what the chimney and the vents do. So in other words, if they're not set up properly, if they're not functioning properly, well, right off the bat, you're probably most likely going to have abnormal combustion analysis, and you know, adjusting air bands on burners and gas valves is not going to be the answer. So right off the bat, we have to be experts on a lot of things when it comes to being combustion experts. And one of those things we have to be an expert is identifying inherent installation errors and venting issues. In these pictures here, real quick, you have an improper vent on a gas plastic vented system in the corner in that little alcove. That is an improper installation and would lead to flue gas recirculation or cross-contamination. The picture on the right actually shows cross-contamination physically happening. So you can see that there's a couple of problems here. In the picture on the right, you can see exhaust gases coming out what should have been the air intake. And they're blasting out top and bottom. And if you look close, you can see from the bottom, there's almost a horseshoe effect happening with the flue gases being drawn directly back into the intake pipe, which should have been the exhaust pipe. So in that particular scenario, if that technician didn't actually see that thing venting in the back of the house, it may be difficult to figure out why he can't get his combustion settings properly. And we're gonna touch on that a little and make we'll be clear on that as we go. For you oil guys, having to step up outside of the house and take a peek and look at vent terminations also is pretty key, because you may find something obvious. It may be more difficult to locate a problem, but if these vents aren't working right, well, we got a problem, because I'll tell you what, in my not so humble opinion, the vent is simply the most important safety device on the appliance. I mean, without pulling any punches, what's the vent doing? The vent is basically taking what could be poisonous gases, in worst scenario, deadly gases, and taking them and moving them from a conditioned space to the outdoors where they're diluted and certainly become less or not a hazard to the occupants inside. So if the device that's moving poisonous gas out of the space is argumentatively, I think it's the most important safety device. If that's not working right, then your combustion's not working right, and the safety of the occupants becomes in jeopardy. Another thing we want to take into consideration is on vent pipes, especially on vent systems, right off the bat, is if they're built properly. So the bottom line is, if you look down at the bottom of that slide where there's a little highlighting, the bottom line is, if you ever have any question on the material, whether it's approved or not in your application, then contact the venting material manufacturer and ask them directly what the limitations are on that product and whether it's applicable for your job or not. So there is a level of due diligence that needs to be applied. So of course, whether you're working with gas or oil, there's various materials to work with, and we want to just make sure that before we go put a combustion analyzer in a pipe, well, we better make sure that that pipe is actually working right. So, I mean, you have venting options these days when you know, couple of natural draft and power vented induced and things like that. But now you have your balanced venting and unbalanced venting, pressurized, negative pressure. I mean, we really know, we have to know what we're venting into, how it's working, if it's appropriate for the job. Again, if the vent doesn't work right, the combustion's not going to work right. One of the things that's required for proper combustion is time. You need to hold those hydrocarbons in the heat exchanger, in the combustion chamber, long enough for a complete burn and for the energy to be exchanged. And one of the many functions that a vent does is provide just enough back pressure or static pressure against that flame to hold that combustion inside of that heat exchanger. So again, if the vents aren't configured right, it's going to relate to several problems, most certainly including venting. So various options, and each one of these options, whether it's a sidewall vent on a mod con boiler, snorkeling, quite often we have to configure pipes to come up higher than snow grade. We're coming out of the side of homes, we're perforating quite often right down around grade level. So we have to bring these pipes up above grade, and even the way we do that is very specific and precise. And there's diagrams laid out in all the install manuals. So you have to know, how all of these systems. I mean, yes, it seems daunting, and most certainly it can be to, especially someone just getting new into the field. But the bottom line is, if we consider the vent the most important safety device, well, I'd be boning up on vents pretty quickly and early in my career, and learning about it. You also have unbalanced vent configurations where you can have pipes going through roofs and shorter pipes coming in, and understand that unbalanced is okay in certain configurations. Using indoor air for combustion air. Quite often, if there's enough air in the room, people aren't bringing an air intake pipe to the appliance. But I'll tell you what, it's never recommended to use indoor air for combustion air, because quite often the quality of the air is considerably poorer than bringing it from outside, not to mention getting into negative pressure situations. I like this little diagram here where it shows how you can use the dimensions of an adjacent room in your cubic feet of air calculations. But I tell you, as my 23 years as a contractor, quite often I've come back to these jobs, and those vents that used to be in those walls are now sealed up because it was a little noisy in the TV room, or they were always, quote unquote, getting dirty. So we just sealed them up. And as you know, what will happen now, you'll have your negative pressure and it goes back to your combustion. So when we talk about confined and unconfined spaces, the bottom line is if you have 50 cubic feet of air per 1,000 BTUs, well, then you're in an unconfined space, and technically you don't have to bring combustion air in. But again, remember, it's always recommended to bring the outside air in when you can to avoid negative pressure, higher infiltration factors. There's a whole host of reasons, pets, dry or lint, all sorts of things. On the right, there's a picture where the architects pretty much like to have all our heating systems now stuffed in these tiny little closets. So obviously there's a demand to bring in combustion air to a system like that. And just as important as the vent, those air intakes become crucial in the combustion process. So when you're servicing appliances that have air intakes, pay just as much attention to that air intake as the vent. Preferably, you would think of them as one. They work as one. We have to be cognizant of where the vents are terminating. There's a lot of rules and regulations about windows and mechanical openings and mechanical air intakes, et cetera, et cetera. So all of these things, I mean, it's a lot, but they're in the manuals. We should be able to find them. And once again, any questions, you always run it by the manufacturer. I know I'm laying on this vent pretty heavy here, but I can't stress enough, if the vents aren't right, your system's not going to work right. You have maximum and minimum lengths on all these vents, and exceeding maximums or going beyond or below the minimums are going to cause their own particular host of problems related to combustion and safety. Just like sizing a circulator pump, when you have all your fittings out there and you're figuring your head, there's flow restriction of your flue gases through the fittings of the vent pipes. So we need to be aware that there are friction equivalences, and we have to figure all that into our lengths of our balanced and unbalanced systems to make sure that we're not suffocating, if you will, the equipment. So,
hey, Kevin, I've got a question here for you.
Yeah.
This is from Robert O'Brien. Do you consider objects in the cubic foot calculations? He has hoarders in mind.
Oh boy.
That's a good question. I haven't heard that one before. That's a good question.
It's a great question, but I tell you what I'd be concerned with hoarders too is I know it sounds crazy, but here comes the technical geek in me. You have a lot of off-gassing that's going to occur in that situation where you could be actually contaminating the combustion air coming in. So whether or not it's for area, I mean, even for just for safety, I'd be bringing in outside air in those situations because the bottom line, a hoarder is only going to occupy space, unfortunately. I'm no expert on hoarders, but I've also had them as clients when I was a contractor, and I know for a fact that when the family comes in and cleans one room, a week later it's packed again. So it's a unique situation, and I would just take the guesswork out of it and bring air to the appliance and go on the safety level aspect of it. Good question. So. Of course, all the individual states, they may have their individual bylaws and things to consider also. And when it comes to homeowners and vent pipes, you know, there is a responsibility of that homeowner to keep the vent terminations, et cetera, free of snow, ice, or any kind of blockages that could cause backup of worst case scenario carbon monoxide into the home. So don't assume the homeowner knows that. Common sense isn't as common as it was in the old days. So make sure that when you have the ability, you address the homeowner and let them know that that is their responsibility, also to maintain the equipment too. So why is combustion analysis important? Well, to me, the most important thing out there is people. So combustion safety to me is first and foremost. It's my duty, if you will, as a technician to apply due diligence and make sure that the occupants that are in that building or home are safe. And you're not going to do it with an eyeball. You have to take readings. As we know, carbon monoxide is a byproduct of combustion, and if the combustion is out of adjust, it could get pretty deadly levels pretty quickly. So we always want to make sure that we know how our combustion is operating. So the only way to do it is with a combustion analyzer. For fuel efficiency, 1% increase in efficiency nets approximately 1% of fuel savings. I think an easier way to say that is a well-adjusted burner, whether it be a gas burner or an oil burner, is going to run anywhere from 5 to 20% more fuel efficient than one that is just, hey, that kind of looks good, that flame looks good to me, let's lock it down and go home and hit the links. My golf league is teeing off in 20 minutes. That's not fair to anybody. So combustion efficiency, that's important. Environmental measurements, of course, carbon monoxide, nitrous oxide, they're all hazardous to the environment. And CO2 is definitely a greenhouse gas. So we want to make sure that our equipment is operating within the normal levels that are prescribed by the manufacturer. And of course, combustion analysis for preventive maintenance. I tell you, guys ask me all the time, you know, do I have to open up the heat exchanger every year on a boiler? And every year I open it, it's clean, it's spotless. And you know, I mean, there's a couple ways of going about that. Well, you most certainly have to know what's going on inside of that heat exchanger if you're there working on it. And the way you can tell very quickly is to put an analyzer in the vent pipe before you even touch any nut or bolt on it, and just take a before reading. This is how I found it. This was the condition it was running when I showed up, and I realized that it was running terrible. And the heat exchanger is obviously dirty. The CO and CO2 are very high, which indicates a dirty heat exchanger, a problem. And you know, they can be very useful to help diagnose problems like cracked heat exchangers and leaking appliances also. So the bottom line is, a combustion analyzer is really the best tool out there to ensure safe, reliable, and efficient operation of the burners, of the combustion process. So things that we're going to be checking and testing, draft. Well, draft is extremely important. We can't have too much draft. We don't want too little draft. An oil burner, if you have too much draft over the fire of an oil burner on a retention head burner, literally you will start pulling the flame right off of the retention head, destabilize the flame, and start making trace levels of smoke, which becomes soot, which, you know, the rest of the story there. So draft is extremely important. Smoke, when we're dealing with fuel oil, quite often we like to adjust to a trace of smoke and then raise the efficiency by 1% and get that smoke back down to a zero smoke, that 1% for efficiency. But the smoke, of course, is an indication of the flame quality, and it's a great place to start. I certainly don't want to stick a very expensive analyzer in a vent pipe that's running, you know, at a number 9 smoke before I realized, and I just clogged up all the sensors on my expensive analyzer, and all I had to do was literally either look at it or run a little a smoke test in there. So excess air. Well, excess air, we'll talk about that in a minute. It's important. We need it to maintain our highest efficiencies, but it also can be an enemy. There becomes a point where you have too much excess air and you start to radically decrease the efficiency of the equipment. Stack temperatures, indication of all sorts of things. I mean, you may be perfectly well and adjust and have high stack temperatures or lower than normal stack temperatures, which could indicate things like air is getting in through you know, a crack in the coping on one of the sections of the boiler or something like that. So again, by being able to know what the abnormal reading is, to find that anomaly, I say by default you become a better technician the more you use analyzers. Carbon monoxide, I mean, what more can I say about carbon monoxide than it's a deadly gas. Colorless, odorless, tasteless, and very deadly. And if I can't smell it, see it, or taste it, well, I better have an instrument that can sniff it out, because if it's around, I don't want to be there. And of course, when you get into commercial, industrial, and in some residential applications, and in the future, most certainly nitrous oxide and sulfur dioxide measurements. They're a byproduct of combustion and a pollutant, and we can measure and negate the production of NOx and SOx. So, all right, on a new installation, that brings its own host of procedures, if you will. So I can't stand plug and play. I hate that because it doesn't show any due diligence. It doesn't. There's no effort there towards safety. You have to follow the rules. You have to follow the guidelines and do the checkoff lists and make the measurements and make sure the thing's working right. So the good thing is all of the information is laid out for us. We have the installation manuals, we have service manuals, and we need to follow proper procedure to make sure everything's working right. So I just want to point out in this installation manual, on the checkoff list here on the startup checklist, in yellow it says, has the boiler been vented properly, of course. So I would say that's pretty important to make sure all that's done right. And then down there on the startup number 7, it says, has the boiler been started and CO and CO2 been checked? Well, the only way to check CO and CO2 is with a combustion analyzer. So it does state in several places that a combustion analyzer is required. So here's a new installation where we have a good friend, John Sawyer here, and he's adjusting a burner. So he's down there changing the fan speeds, and there's the probe in the vent pipe measuring the flue gases to make sure that everything's adjusted properly according to these settings that are in the manuals. So again, in yellow, use a combustion analyzer to ensure CO and CO2 values are within range. It says again in the warning, use a combustion analyzer. Throttle adjustment, here's one of the ways that we are going to make an adjustment to the flame and change the CO and CO2. It says for any reason it needs to be adjusted, it's important that an analyzer be used. The bottom line is any of these adjustments, they can't be made unless you have an analyzer. Even oil burner settings, making sure that the right nozzle is in there can be a big issue. Even if the igniters are incorrectly set and dipping into the flame cone, into the oil cone, that could be messing up your combustion right there. Pump pressure levels and the head and air adjustments are correct. These are all things that, of course, there's the air gate. There's the ways that we're going to be changing the CO and CO2 and smoke levels. A little notable quote here, and this is from one of the dreaded enemies, the insurance company adjusters. So they know very well. This is in one of their guides. An analyzer is even more important with modern equipment. The operating data specifies adjustment of the burner in terms of waste gases. It's simply not possible to adjust it in any other way. So in other words, they're saying, I don't care how many years you've been in the business and you looked at the flame and it looked like it had nice little blue tips on it. That doesn't cut it. That doesn't cut it. So looks good to me. The eyeball method, no more. Doesn't work. So we can guess, right? No. We have carbon monoxide again we have to worry about. So that analyzer is going to be able to smell that for you. So just so you know, approximately the average is about 20 technicians are killed by carbon monoxide annually in the United States. That's a big number in my opinion. And that can be avoided by using if you have no other means and you have a combustion analyzer, well, you can put the analyzer in an ambient air mode and check for carbon monoxide in the rooms that you're working in, especially if it's in a confined area. So we don't really need to get into all the problems of CO, but the bottom line is the more of it that's in the room, the faster that it can get us to the hospital and even kill us. And the fact of the matter is, even long-term exposure to low levels of CO is very bad. So I mentioned if you have an analyzer, you can put it on ambient CO and just check for the carbon monoxide content that's in the room. Another thing that's happening quite often, and frankly, I know I sound like a stickler here, but combustion analysis is so important that quite often there are fire departments or inspectors that are requiring that the technician stand inspection actually perform the tests in front of them. That's how important it is. So I mentioned due diligence. The care a reasonable person exercises to avoid harm to people or property and reasonable steps in order to satisfy a legal requirement. Well, I'll tell you what, being able to print off a flue gas analysis and have that as documentation, especially I mentioned earlier, doing before and after tests as a CYA is fantastic. I can say, hey, listen, this is exactly how I found it operating when I showed up, and I did X, Y, and Z according to my procedures, and when we were done, we set it back up and ran off another printout, and here's our documentation to prove that. As opposed to saying, I don't know what happened. I mean, I looked at the flame looked awesome when I was done. I closed the damn door and I went home. The thing was working beautiful. I've worked on these all my life. It doesn't cut it anymore these days, unfortunately. So I used to tell my guys when they work with me that little printout, unfortunately, when you get into a sticky situation, that little printout literally could be your get out of jail free card. If you don't have it, well, then everyone starts pointing the finger because all the technicians know the last screwdriver rule, right? Doesn't matter what happened before you got there. You were there. You put a screwdriver on it, you own all the liability now. That's the way it seems to be. So the analyzer itself. The analyzer is going to be an investment, and it's not only an investment in money, it's also should be an investment in time to learn how to use it, okay? Most people, including myself, you hand them an analyzer and expect them to know how to run it, know what all the values mean, and how to analyze it and reference it. It's daunting. There's a lot there, but bottom line is, don't buy an expensive piece of equipment and not know how to use it. So the bottom line is read the manuals. That's first. Find out if the manufacturer has training that you can go to and actually learn how to use that. On-the-job training. Make sure that you're going out with your technician and making sure that they actually know how to use that analyzer to their full advantage and what the readings mean. And that, in fact, that they're using it right. You don't just stick an analyzer in a vent pipe. The vent hole has to be in a specific place so it's not reading diluted gases or something improper. So another thing to consider with combustion analyzers is maintenance and calibration. Now, if the analyzer hasn't been calibrated within the manufacturer's specifications, then the readings are invalid as far as, when I said that it could maybe cover your ass in a legal situation, maybe, this is how it was running when I left. Well, if your analyzer hasn't been adjusted or calibrated in 8 years and it's beyond the manufacturer's recommendations, well, then those readings are in essence invalid. And be careful of where they say you can do field calibrations. You can certainly replace sensors in an analyzer and punch in the code that it gives you and it does a self-calibration. But be careful on whether or not that constitutes the calibration as required by the manufacturer to make sure that it's covered in all legal aspects, if you will. So why are we testing? I mean, property damage, we don't want to be responsible for be replacing siding, and I don't want to come home someday from a hard day's work and walk up my front steps and see something like that. That will not be a fun phone call to anybody. We need to know about what's going on inside of the vents too, not just whether or not the readings are right, whether we're getting condensing issues and things like that. It can all be figured out by the combustion analyzer. We can't look at a flame anymore. We don't want puffbacks and things destroying homes. We need to be testing, not guessing. So we can use our analyzer to find cracks in heat exchangers. There's several tricks that we can use, including understanding that if we're doing combustion analysis on a furnace and all of a sudden the blower fan comes on and our O2 starts going up and our CO2 starts going down and we're wondering what the heck's going on, well, the only thing that changed at that moment was the blower fan came on. That should be a clue right there. You can do draft readings and with no combustion and check the static pressures and see if your static pressures are changing in the combustion chamber just by turning the fan on and off with your draft gauge. You can have a gauge that's sensitive enough to be able to pick up cracks as tiny as that in a fire tube. So there's no way in hell we're going to find that typically with an eyeball very quickly. But with a gauge, we know that we have the problem because we can sniff it out. So you might have heard the term stoichiometric. Well, that's perfect combustion. Well, unfortunately, perfect combustion is theoretical because there's limitations from the equipment that we have that burns the fuel that has inherent waste, if you will. But if we look at this curve, excess air comes up a lot. And if we look at where excess fuel, stoichiometric combustion, and excess air meet, that would be perfect combustion. If you go up to that efficiency red line, and you notice the efficiency actually isn't at peak performance yet at stoichiometric, that theoretical perfect combustion. We actually give it a little bit of excess air, and with that little bit of excess air, we burn off the rest of the hydrocarbons, and you notice your efficiency goes up. But there is a point, there's a balance point. When you start giving it too much excess air, your efficiency starts dropping dramatically. When you adjust by using fuel on the opposite side, excess fuel, one of the things we have to take into consideration is look how quickly we can generate carbon monoxide by adding fuel on the other side of the stoichiometric scale. So whether we're adjusting the air or adjusting the oxygen, of course, we're adjusting the CO and CO2, the efficiencies, et cetera, but there is a fine line. So when you hear about excess air is necessary, but I mean, typically in a perfect world, we would only have about 5 to 10% excess air on natural gas and somewhere around 5 to 20% on fuel oil. But quite often on like fuel oil systems, I've seen excess air running as high as 50%, and the technician telling me that it's running correctly. So obviously there's a little disconnect there. There's a little training required. So excess air, once we go beyond that point, it starts to lower the efficiency. So it will lower the CO2. We can see that on our readings. The stack temperatures are going to increase. As the volumes of gases increase, the velocity is going to increase, causing stack temperature to go up. So when the stack temperature is going up, your efficiency is going down. Remember what I said, if your velocities are going up, you may actually be not allowing that fuel enough time in the heat exchanger to absorb the heat, causing unburned hydrocarbons, and again, higher losses. So the longer the gases stay in the heat exchanger, the more extract. So the bottom line is the hotter the system, the hotter the flue gases, the more waste that's going out. So going back to hydronic systems, if we can design lower temperature systems, including lowering our flue gas temperatures, we can save everybody a lot of money. All right, low CO2. We're getting near the end here. Low CO2. When the level is too low, of course, a bad combustion situation exists. So here's some straight up reasons why we have low CO2. So if you can't get that CO2 to the reading that you need, typically it's an air to oil blend mixture. You gotta adjust that air band. Poor atomization. Maybe the oil tank is outside in the cold and the oil is getting very viscous and causing, like on that scale I showed you, an increase of fuel on the scale, which be careful because that also can increase carbon monoxide. Incorrect chamber design, construction, not allowing proper time in the combustion process, excessive draft, we talked about that. Obsolete burners or damaged parts, of course. Underfired. You see these big old boilers and they have a draft problem, so they go in, throw in a 0.75 nozzle when it was supposed to have a 1.5, and that's going to have its own host of issues too. You may not get those stack temperatures up high enough because now you're under fired, and you would have your low stack temperatures, condensing issues, all sorts of problems. Now with gas, maybe your manifold pressure is too low, bad offset adjustment, excessive pressure drop, so not enough gas supply. The mixture, of course. Cross-contamination, I mentioned that before, drawing flue gas in. And by the way, the easiest way to know if you have cross-contamination, drill a hole in the air pipe and put your analyzer in the air intake pipe. If you have a CO or CO2 in that vent pipe, or the O2 level, the oxygen level is less than 20.9%, then I guarantee there's contamination in that pipe, and that's causing your combustion problems. So again, that analyzer is used as a diagnostic tool. Damaged parts, of course, will be a problem, or we mentioned under firing. So the bottom line is, if you're not testing, you are guessing. And if you're guessing, boy, you're certainly increasing your liability potential. As they say, you're sticking your ass out there in the air. So you want to set it and forget it. You remember Mr. Bo Peel? Set it and forget it guy? That's the guy you want to talk to. I mentioned by default, you become a better technician. By all means, the more you talk about excess air and CO and CO2 and carbon monoxide, the better of a tech you're going to be. The easier it is to explain to customers why you need to take their system apart and reconfigure their vent properly, et cetera, et cetera. And the bottom line is, in my opinion, in my, again, not so humble opinion, that's why I test right there. For those people that are sitting upstairs that are relying on me to have the professionalism to apply the due diligence that's required to make sure when I go to bed at night, I'm going to wake up in the morning. Okay, and I would be remiss if I didn't talk about smoke detectors if we talked about carbon monoxide. So please remember to remind your accounts to change batteries or replace outdated carbon monoxide detectors. You'd be surprised, those 10 years goes by pretty quick sometimes on those carbon monoxide detectors. So anyway, thank you very much. I mean, combustion, I was saying to John, it's a dance, it really is. You know, the velocity of the flue gases is like the tempo of the music. Some systems can handle, you know, faster dances than others, but if those gases aren't moving from the air intake to the tip of the exhaust at the right velocities and the right mixtures with no contamination, that's what we want to see. And the bottom line is, we need a combustion analyzer, no more eyeballs. Anyway, thank you very much, and thank you, John, for the opportunity.
Oh, Kevin, that was awesome. Thank you. And yeah, it goes back to something you said this in any one of a number of different instances over the years. Professionals don't guess. They don't guess on pump sizing. They don't guess on boiler sizing. They don't guess on anything. They do the math. And when it comes to combustion, they do the math. You know, they do it right, and they do it properly. They make sure that this stuff is done in a professional manner, and that you know, that we have, you know, that we have the right numbers, and it's done by the book. That's what makes this. That's what makes us professionals. That's what puts us in that's what separates us from the handyman. You know, a handyman can put in a boiler. You know,
Absolutely.
That's not that hard, right?
Absolutely.
That's not that hard at all. All righty, we got some questions here for you. Dave, do we want to do anything before we get to the questions? Oh, before we get to the questions, let's give us the trivia answer.
Oh,
the trivia. I'll do the trivia question answer first. All right. So as of right now, 8:16, Gerald, that's the last one. All right. A lot of you guys got it. The trivia question was, you know, what two other films did George Roy Hill direct with Paul Newman? And they are, of course, Butch Cassidy and the Sundance Kid from 1969, and then from 1972, the winner of the Best Picture Academy Award for that year was The Sting. The Sting. So two of my favorite movies, absolute favorite movies. So those are your, everybody who got the answer correctly, we'll put into a little spinner next week, and we'll pick a winner. And we're going to pick the winner from last week's coming up just shortly. But again, a lot of questions came in, a lot of comments came in, Kevin, during your discussion, and I want to try and throw a couple at you here. A lot of great comments. I get from George Conrad. What are good numbers for ModCon boilers for stack temperatures, CO2, O2, excess air, etc.? Are there certain numbers that we're kind of looking for?
Yeah, absolutely. But they're going to vary, especially with modulating boilers. But they vary on very small scales. So typically with natural gas, I mean, we're 7.5 to as high as maybe 9.5% on the CO2. And CO, typically they're going to range from 0 when they're firing in low fire as high as well, they say the safest level, a safe level of gases at a high fire on some of the larger appliances could be as high as 175 parts per million. But quite often, the amounts that we measure are significantly lower than that. So like in low fire up to about halfway on a gas system, quite often we have 0 parts per million. And you don't see, maybe 60, 70 parts per million on your high fire. Things like that. So, I mean, it's going to vary. When you get into propane, of course, the higher caloric content is going to raise that number. So your CO in CO2, well, your CO2 will come up a little bit. So instead of 7.5 to 9.5, you'd be like 8.5 to as high as 11.5. In that ballpark, but they vary. The bottom line is look at the manufacturer's installation manuals, and they're typically right there. And another thing, on new installations, I tell technicians quite often that when you put your analyzer in the vent pipe on a new installation, quite often it's a confirmation process, not a gas valve adjustment. So these tests, a lot of these boilers, the majority of them are tested before they leave the factories, and they're adjusted and tested. So quite often, when you put your analyzer on them, it's not surprising to find out that they're already firing exactly the way they're supposed to. So it's a confirmation process. But if it's a propane system or the at certain time of the year, if the gas pressures are low on natural gas, or they're putting some kind of another inert gas in there to boost it up, those are all the things that can affect those readings. So, but the bottom line is, I know a long-winded answer there is they do vary, and they will go up as the caloric content of the fuel goes up.
Very good, very good. Hope that answered your question. Here's one from Robert O'Brien. Given the increasing biodiesel in heating oil, particularly in Massachusetts, do you recommend using O2 instead of CO2?
I have to be perfectly honest with you. I am not an expert on biofuel. When I cut my teeth in oil, but it was right when that biofuel was really starting to get a hold. But I do know one thing. It's a science. So whether I'm reading my CO2 or O2 values, they're proportionate to each other. So we're going to end up at the same place, whether you're going to read one reading or another. I do find that your CO2 tends to change more rapidly. It's read, it's displayed more rapidly on the analyzers out in the field, and with some equipment, they heat up so fast that hitting steady state and taking a test, it becomes an art in itself. So I personally look at CO2 a lot. It depends on the system, but the bottom line is either way, we're going to end up at the same place because the science of the flame is going to dictate that.
Very good. Here's a good question. What's the difference between combustion efficiency and appliance rated efficiency? Because that's always a question you'd get from a homeowner. I mean, what's the difference? But how would you explain that?
Boy, that's a fantastic question, and boy, you hit on a topic that I'm kind of passionate about, because I feel I agree with the folks over at Energy Kinetics about AFU being somewhat of a flawed science, because AFUE is, in essence, it ends up being pretty damn close to what your combustion analysis is. It becomes the system's ability to burn a flame, but it doesn't take into account the system's ability to manipulate the BTUs from that flame, whether they're disappearing out the chimney or the system design was terrible. AFUE is flawed, but the bottom line is this. Your AFUE readings, so say if you're running, you know, your boiler, you say I bought an 87% boiler, an 84%, you know, oil boiler or whatever. Typically, your combustion analysis is going to be a few percentage points less than what you see in AFUE. Now, technically, they're not exactly the same. AFUE is annual fuel utilization efficiency. It's an estimate on the usage of the fuel through the complete season. I mean, you're talking to a guy that feels it's so flawed right off the bat, because if your boiler's making domestic hot water, well, AFUE means nothing, because the AFUE is a test that's designed for heat-only applications. So right off the bat, if you have a house that is tight and it was set up with an unbelievably efficient hydronic system and low temperature, and you put an 84% boiler in there, I tell you what, that's going to run probably just as good as a 90% boiler if that 90% boiler had a crappy system attached to it. So it's an AFUE, in my not so humble opinion, is a flawed science, but I'll rephrase. Your combustion efficiency will be pretty close to what AFUE is, but it's usually a little bit less. Did that long
Okay, very good.
make any sense at all?
No, that was it's a long way to get there, but well worth the journey. Very good, very good.
Clear as mud now.
A comment from
Well, it's
yeah,
mud.
there we go.
It's like AFUE.
Yeah. Well, or as they said, as a kid, simple AF UE. All right. Okay, good. Okay, we got it. Steve Nugent says, failure to do a combustion analysis every time the appliance is serviced is a huge liability issue. Technicians should test every time, regardless of the nature of the service call, even if someone accidentally shut off the switch. It's that important. Yeah, I agree with you. Absolutely. Boom, 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 boom. Should boilers that are able to deter, go ahead.
If I may interrupt just real quickly, I mean, when you think about it, and when you weigh out all of the potential problems that could happen by not taking the test, if your intention is to literally just see what's going on in the vent pipe, how long does it take? In all honesty, 5 minutes? You know, so I mean, it's not a huge time investment. You know, if you're one of those companies that you got to send a guy back to the service manager's shop to get to the one analyzer that they never use, well, of course I can understand that'd be a pain in the neck, but that's not the way you should be using that analyzer anyway. So I do agree. Anytime you're doing service work, if you want to cover your ass, pop it in there and just see how it's running.
Absolutely. All right. Here's a good one. Should boilers that are able to determine their own gas type, for example, LPG or NG, have a combustion analysis because the manufacturer certainly doesn't suggest so?
Okay. I've never heard a manufacturer saying don't use one. You know, now whether or not it's needed in the adjustment for a gas valve or something. Now I do know of self-adaptive technology that can sniff out its own gas and make its own adjustments, et cetera, et cetera. But once you hit steady state on whatever particular gas that appliance would be using at that time, wouldn't you want to, just as an insurance policy, pop that analyzer in there and sniff the gas and make sure that the mass airflow sensor is actually working right? I mean, to me, it comes down to, again, due diligence. It doesn't take long to do these tests.
All right. And it's being professional. Yeah. From Tim Doran. Tim Doran, how you doing, my man? Louisiana State University has some great stuff on CO. 9 parts per million is the EPA recommended limit in residences. Even 9 parts per million can be harmful if the exposure is long-term. Humans cannot eat waste CO, so it accumulates in our system. 70 parts per million for several hours could be fatal. That's disturbing.
It is disturbing, and the problem with CO poisoning is you know, your average human being, by the time it's got to the point of critical mass, it's already too late.
Yeah.
By the time you know that you've got carbon monoxide poisoning, it's too late. So again, use technology. Put a chirper in your pocket. I mean, the bottom line is use a little common sense too. If I'm going into what I know is a confined space, I mean, I'm going into a tiny little closet. It's got a 1 million BTU boiler. I mean, come on. I want to live to see my wife that night. I'm going to go in there with a chirper, and if I don't have one, and a chirper, by the way, is a little device that goes in my pocket, and if it sniffs CO, it's just as good as having a canary in the mine. It starts chirping for you. So if it chirps, you don't have a discussion. You turn around and you leave. So, you know, if you don't have those kind of devices, which are very inexpensive these days, use your combustion analyzer. Take a sniff of that space before you go in there, and take a reading every few minutes or so if you think that, you know, you're in a compromised position. I mean, the bottom line is I mean, it's your own ass, right? I mean, gee whiz.
Yep. Robert O'Brien asks, what's the difference between CO and CO air free?
CO and CO air free. The air free is a calculation that the analyzer makes that removes the free air that's in there, and it's just strictly measuring. It's subtracting the oxygen that's in there, the excess air. You're only reading the carbon monoxide. It's undiluted. I guess is the way I should answer it. So when you have air-free or CO test, it really what it comes down to is whether you're taking the test in the pipe or you're taking the test outside of the pipe, right? So you want to do your CO tests with the air-free, and then I'm sorry, I'm having a little mental block here. But the bottom line is it becomes a calculation, so we're only measuring the carbon monoxide that's in the gases, not the diluted gases.
Very good. Now, when you get to be our age, Kevin, those mental breakdowns happen more and more often. There we go. Do modulating boilers have built-in combustion controls? Or say again?
I'm sorry, I interrupted. Go ahead.
Do modulating boilers have built-in combustion controls or sensors? Asked Manson Frame.
Could you ask that again? I'm sorry.
Do modulating boilers have built-in combustion controls or sensors?
Well, we just mentioned that there. I mean, I was aware of one that was on the market a while ago. I don't know if it's still on the market or not. That did. But most your average residential stuff that I'm working with most of the time, no, you'd be paying a premium for that. And I don't see that as a technology that would be purchased. I do know for a fact that a local New England company put out a boiler, and it had self-adaptive technology, and it had everything that it sniffed its own gas, exhaust gases, et cetera, et cetera. But the premium on it was too high. People didn't buy it. And that did say you didn't have to adjust it with a combustion analyzer, but you didn't have to adjust it with an analyzer, but you certainly wanted to check it and make sure the performance was proper.
Very good. All right, well, we got a lot of good questions here. Here's another one. What about the use of #1 fuel oil in oil burners designed for #2 fuel oil? One of those questions where mixing #1 with #2, it's never a good thing. You know?
No, that doesn't sound good to me. I'm not an expert on heavy fuel, so I don't know if they're using it to dilute it or using it straight up. I don't know, but I'm not an expert on that. I know you'd have viscosity issues and light off issues, and you know, that's not my area of expertise, just to be honest.
Good, very good. Does Kevin remember the old chemical analyzers?
Oh, hell yeah, I still have one.
Good, very good.
And
So would high altitude,
they work perfectly fine, by the way. They just take more time, that's all.
there you go. Would high altitude more likely require an adjustment from the factory settings? And a follow-up question, does elevation affect numbers on combustion efficiency?
Well, most certainly, because your oxygen content is depleted as you go higher in the altitude. So that's going to make a big difference on how much combustion air is being delivered to the flame. So I do know that a lot of manufacturers that sell equipment in areas like the Sierra Nevadas, they're kind of set up for that. You look at the nomenclature and they're already programmed, their algorithms and fan speeds are set up for that. Manufacturers that make a unit that's good for everywhere in the country quite often have dip switch options that you'll have to switch when you get into higher altitudes or come to a lower altitude for that matter. So that is something that is addressed, and it is typically part of, especially modulating condensing technology, that is definitely taken into consideration. Absolutely, absolutely.
Very good. This is from Dan Cook from Mont McLean. Although our natural gas boilers are test fired at the factory, the combustion reading is critical to let the technician know that the boiler is running correctly after it's been bounced around in shipment. And the length of the exhaust and intake pipes are not the same length that are used at the factory during testing. Combustion readings let you know that everything is running properly and that the boiler is tuned to the exhaust and intake lengths in the field. I think that pretty much covers it, does it not?
That's exactly
Absolutely,
correct.
Absolutely.
That's exactly
and, from Jeff House. Yeah, Jeff House says new commercial boilers do like the new commercial boilers do like ours. They have O2 and CO2 sensors, and the check and adjust all the time is running. All the time it's running. Some others do spot tests. I think it must be talking and ECR as well. And I think a few other guys mentioned some other boilers that might have some of that, some of those the sensors built
House, Mr. House, is that
Jeff
the
House?
Is that the infamous Mr. House from Canada?
That's the infamous Mr. House from Canada. Mr. House is in the house. That's right.
Taking me on to, what was that, Clamato, whatever. Here in Queensbridge. My God, I'll never forgive him for that.
Yeah, what is it with Canadians and Clamato? I don't understand that at all. God.
Good guy, I do miss him. Great guy. I enjoyed his company.
Yeah, he's one of the best, and a new grandpa, by the way, too.
Oh, congratulations! That's
congratulations.
Yeah, absolutely.
There's an interesting question. Do manufacturers provide required combustion values, or do you just follow the standards? That's a good question.
Can you say that again?
Do manufacturers provide required combustion values, or do you follow standards?
No, manufacturers will provide very specific settings and specific CO2 ranges. Absolutely.
Right, very good. Is it true that only measuring CO2 does not indicate whether a combustion process is running fuel rich or lean? Asked George Conrad.
When you compare the number to what the value is stated in the instructions, that's where I'm going to start. Now, is it going to answer why it's a low number immediately? No. I mean, I'm going to have to do some investigation on that. So I think I'm answering it wrong. Can you say that one more time?
Sure.
He's talking about the fuel. Is it running lean or is it running rich? And can you tell just by reading the CO2?
Okay, yeah. Well, you can certainly tell that there is a problem as far as running lean or running rich by the CO2, but you don't know where that air or lack of air is coming from. So if the air is infiltrating in from an old system, and say you have an old dry-based boiler and all the coping is burnt off of it and it's sucking air in there, well, that could be the reason why you have an abnormal value. Now, it does affect the flame, but that wouldn't be an issue where you're going to adjust it with an air gate or a throttle valve adjustment. You see what I mean? That would have to be further diagnosed to find out that it was in essence an excess air problem coming in from a secondary area, infiltrating into the system where it shouldn't have been. So yes, it's an indication of that, but it doesn't necessarily, unfurl the flag out of the end of the gun that says change this part. We have to do a little bit more investigation.
Unfurl the flag from the end of the gun. I like that.
You remember those?
That says, yeah, instead of saying bang, it says change this part. I like that.
That's right. Exactly.
I'm going to steal that. I'm going to steal that.
You got that.
Dave Yates has a comment. 1976, my boss said to me, "You're in charge of our gas and oil installations." And I think even back in 1976, Dave Yates was old, if I remember correctly. The fine folks at Sid Harvey showed me the analyzers and said I needed the O2 one to ensure I was on the correct side of the Stoic scale. Stoichiometric, is that the word?
Yep.
Stoic scale to minimize CO. My bosses damn near had a heart attack when the bill came in. Just prior to the sale of our business in December, I came across several sets of those old chemical analyzers. Hey, Dave just doesn't throw anything out either. He's one of those guys too, which you always know an old plumber, man. Old plumbers throw out nothing. They throw out nothing. My dad, when we cleaned out his shop, there was stuff there from oh my God, from the old days. So God bless, Dave. That's beautiful. That is beautiful. All righty. In Canada, Bloody Mary, it's a Clamato is called a Caesar, or a Bloody Mary in the U.S. I thought it was clam juice, which just seemed just wrong, but that's all right.
Clam juice. There was no Bloody Mary.
Yeah, it was clam juice.
It looks like a Bloody Mary, but it ain't a Bloody Mary.
It ain't a Bloody Mary.
Not when you have like a sandwich on top,
Clams are for frying and for steaming, not for drinking.
That's right. Or well, no, you don't slurp a clam raw. You slurp an oyster raw.
Right.
I mean, how can you tell the difference, really? You slurp a clam raw, it's just kind of gross. But an oyster's okay. I don't get it. Dave says you get the same CO2 reading on either side of the Stoic scale, but O2 will get you on the correct side.
That's true. I'm trying to remember. George Lanthier had a great term for it. I can't think of it right now, but he was a great guy when it came to combustion. Had some talked about the Lambada scale and all this, that. Yeah, he really got into his combustion.
Isn't the Lambada the forbidden dance?
Yeah, it's also a new investment.
Ah, there you go. All right. Well, Dave, hey, you want to do that your spinny thingy?
I sure can. You got to give me the screen.
I am turning the con over to you, Ogie Oglethorpe.
Okay. Hang on. Oh, there it goes.
All right, you guys enjoyed this session? I thought I love having the guest speakers. Kevin, you did an awesome job. Thank you so much. This has been a lot of fun.
It has been, John. Thank you for the opportunity.
Yeah, we'll probably abuse the privilege again, I'm sure.
We could find something. Yes.
That's okay.
Okay, now what was last week's question?
Last week's question was, well, I know the answer. It was Commerce Bank of Beverly Hills and Milburn Drysdale.
Okay, what bank was the Clampett fortune invested in, and what was the name of the bank president? Mr. Drysdale lived right next door to the Clampetts.
That's right. So these are the listed names of everybody that got the answer correct. And so what I will be doing is I will contact you. I will send you an email and ask for a mailing address for those of you that do win tonight, for who does win, if you are online with us now. I've got a bag of goodies. I got some cool stuff shipped to me from Takeo that I'll be sending out to you. Like I got Bluetooth speakers. I got a couple of hats and a bunch of other things. So let me tap to spin.
Oh, you do that. I'm gonna go grab the latest addition to the Takeo goodie bag scale. Hold on a second. You go ahead and do that though.
All right, and here is the spin, and it looks like It's going to be Samuel. All right, Samuel, I will send you an email. I know you're online with us tonight. I saw you there. So I'll send you an email and get a mailing address from you, and I will be shortly sending that stuff out to you. Congratulations.
Woohoo! All right. Well, congrats. Are we going to have one of these in there, Dave?
What is that? I can't see you yet. Sorry, I minimized it. Yes, I will have one of those in there too. Correct.
Yeah, this is the new Takeo mask. There you go. Yeah.
Speak about masks. You guys hear the latest thing that's happening with the youngsters out there? They're dressing up as old people, putting on makeup and like using walkers and things, and they're putting the masks and going into liquor stores and buying bottles of booze.
I have
I
to
like
guess a
that.
heck of a lot easier now. Yeah, right.
It hasn't been so easy since the early 80s.
Oh, yeah, that's the one thing about masks. They do frog up your glasses. That's all right. Well,
You have a face for that mask.
yeah, I mean, a lot of people say this is an improvement. I should do this like all the time.
I'm not one to talk, but you know.
Yeah. Okay. All right, enough of that. Enough of that. All righty. Well, very good. Very good. All right. Well, we can open up to just general questions now too. You know, anything else you guys have? Anything else you want to yak about? I mean, this has again been terrific. How is this? An hour and 45 minutes. Again, this is kind of standard fare for us nowadays. We really do appreciate it in these hot summer nights. How's everything going, man? Are you guys out there doing well? Is business good? These are all things that we'd like to know about. And you know, any unique challenges or any success stories out there? We'd love to hear from you. You know, what kind of interesting things are going on with you guys out there in the really world? Who owned the chief? Who owned the chief? Yeah, I remember that was Denny Lemieux. I think was my favorite character, the goalie. Who owned the chief? All right, and what do we got? We got a great job from Anthony Reichow. When you get Kevin, you don't know this, but when you get a great job from Anthony Reichow, you know you have achieved something, because Anthony is one of the best. Say again?
I sent him an envelope. I wanted my boss to hear that from Anthony, so I have an arrangement with Anthony.
Oh, really? You got envelopes? I have to do automatic payments right out of my account for them.
Yeah, and yeah, they're not that automatic. I got to tell you, there, Dave. We could they could be a little more timely.
Well, no, I meant to Anthony.
Oh, well, why
No,
are you giving it to Anthony? You want just to skip the middleman, send him right to me.
Gonna say, sounds like he's in on something here.
Yeah, good Lord, Dave. Yeah, give that man a cigar, absolutely.
Yeah.
All righty. So, yeah, what else are you hearing? What interesting tales of woe or tales of success have you heard out there in the marketplace, Kevin? When you're out there in the world, are you being able to train in front of people at this point yet?
Well, that's what I was going to mention. In all reality, I'm really excited because I've been able to do face-to-face in Rhode Island and in New Hampshire. New Hampshire first, and then I just this week I was able to train in Rhode Island. So things are starting to open up, and the requests are coming in. My calendar, you know, in all honesty, towards the end here in the last couple of weeks, the attendance of my electronic training, if you will, has been down. I'm not going to kid you. I think guys are getting back in the field, and you know, and I'll tell you, historically, in my line of work with boilers and things like that, I have to say nothing takes the place of hands-on training with technicians, and being able to utilize the trailer that we built over at Emerson Swan as a on-the-job site training. So I bring my trailer right out to the contractors, and that way that minimizes the exposure. We're working with smaller groups of guys, and being able to manage the meeting very well with the social distancing and keeping things clean and sanitized. And the guys that I've been in front of have been awesome. Almost like, you know, they were sort of almost chomping at the bit to get their hands back on some new equipment and start working. So that to me is the newest and most exciting thing. I never thought I'd ever say that, but you know, having that time away from guys, I mean, I'll be honest, I'm most comfortable in front of technicians, you know, working with the folks with the wrenches and folks like myself and people that, you know, are of the wrench, as they say. It's the hands-on. So being able to do that again and starting back up is getting exciting. And but on the same token, you know, learning all the idiosyncrasies of the different areas, and there's still places, of course, that I can't train, and there are places that we're allowed to, but the occupants and owners aren't quite ready to take that step. You know, it is a little different. I mean, I used to love being able to, you know, bring a big box of junk food and donuts and whatever, you know, to a morning luncheon, a breakfast or a luncheon room or something, and that's all out now. You can't be serving food and things. So there's a little bit of a learning curve, but I tell you, getting back in front of people and having that camaraderie and going back and forth, because I don't care if you've been a trainer for 30 years. I mean, every single time I meet with contractors, I learn something new. I pick up on something, a new way of doing something, or, you know, it just, I need that interaction as a trainer. You know, I can't be on the end of a camera all the time. I need to be out there with the guys. So I'm really excited that that's happening again.
Yeah,
that's good. Now you're doing just.
Oh, I was gonna say, it sounds good that you got that trailer, because I hear lots of parking lot meetings happening with people now. You're not going into buildings and whatnot. So having that trailer that you can bring around to somebody's shop may not be the ideal that we're used to, where you got a training center and you get 30 people in there. So you might only get 4 or 5, but hey, we're still training, right? And we're still passing along the knowledge.
Right. And you know, we only have so many products on a trailer that we can work with at a time, and so many people, but something's better than nothing, I'll tell you that. You know, it's a shame that, you know, you have such a facility in Cranston that isn't being utilized for any reason. I don't care for any reason, you know, and I understand safety and all that, but to think of that room and that resource empty is just, it's a shame. So the fact that I'm able to get out there with a trailer, to me, is a great indicator that we're getting close, that those doors are going to open back up. And that's important. It really, really is important.
Yep. And for those of you that are
individual.
not, oh, sorry.
My turn, Dave.
Oh, sir, yes, sir.
Are you training individual like contractors and their staff? Or are you doing kind of open invitation stuff, Kevin, or is it just one contractor at a time? With the
both. Right now, there's still, I'll say there's a little bit of hesitation or reluctance among some of the branch managers to be bringing people and hanging around at the wholesalers. You know, in those situations, I get it. I mean, we've done it. We have done 2 so far at wholesaler locations where we stayed outside with the trailer and nobody went indoors, and we were able to you know, talk to contractors, kind of onesie twosie, have them come in and talk. And you know what's great about those things too? It's not just us being able to show our goods and that's all part of it for sure. But I tell you what, you know, offering the opportunity for a contractor to have a little private one-on-one time and not, you know, and this is no disrespect or knock to a full classroom, but sometimes the intimate situations allow guys to open up their dirty laundry bag a little, where they may be reluctant in front of some of their competitors to do that.
Right.
So there are advantages in all aspects of training, but you know, the intimate setting, it certainly has some great advantages also. You know, it really does. Being able to literally talk to a manager with his lead techs and literally address, you know, immediate concerns, issues, problems that are directly relating to them and their bottom line at that moment, and being able to help and have that camaraderie. I mean, to me, that's what it's all about. I love that opportunity, and it doesn't happen sitting in my house doing, you know, stuff on a camera all the time. I got to get out there and work with people. That's what I do, and I'm so excited to be able to getting that all cranked up again. My wife is like, Kevin, watch out, for God's sakes. My calendar now is like booked through the end of August. It's fantastic. So
No, good for you.
hopefully they'll all pan out. We won't have too many cancellations, and as we go further along, we'll all make the adjustments that we have to make to maintain the safety and the social distancing and that, but get what's more important done, the training. And that's what I do, and that's I love getting out there doing it.
Excellent.
Very good.
And I would say if you're in Kevin's area, look him up, and see if you can get something going. But the other thing I wanted to say, for those of you that are not in New England, that's near Kevin, find your reps, find your wholesalers that do have something like this. These are they spent the money and built these trailers and vans for you guys out there. So I would say in this day, right now, find those guys, talk to them, make them that resource for you to continue your training that we haven't been able to do. And get used to that relationship with them. They're all in it for you. And so look them up, find them out there, and build that relationship and whatnot.
Absolutely.
Very good. Got a comment here from Peter up in Canada. Shipton's Heating and Cooling in Hamilton, Ontario has been so busy that we are 3 weeks behind on installs and a few days on service calls. That's a good situation to be in. Absolutely. I mean, it's things are changing. Things are starting to loosen up for people, and a lot of stuff that's been put off. I mean, in certain parts of the country, I think in other parts of the country it's just going to get worse. Than we're seeing that in Florida and other parts of the country that we haven't seen the bottom yet. We haven't seen the depths of this thing yet. So we'll just see how it goes, and all we can do is keep our head down and keep moving forward, right?
That's right.
And stay safe.
Yes,
That's
definitely.
That's what it's all about. That's what it's all about.
All righty, well, let's do the last go around for questions here, folks. We still got about 62 people after almost 2 hours. We still have 62 people out there hanging on our every word.
Oh, Dan left and he didn't tell us what ice cream he's going for tonight.
Oh man.
All right, I'm gonna have
Dan,
to call him on that one.
Yeah, and every time Dan leaves, he tells us where he's going, what kind of ice cream he's going to get on the way home. So
I'm a man after Dan's heart. I'm a sucker for ice cream.
Oh, what's your favorite kind?
Nobody eats ice cream like New Englanders, and that's
No.
a fact. That's a fact.
That's a proven fact. There you
My
go.
favorite of all time, hands down. There's none better. Haagen-Dazs chocolate ice cream. Period. They make the best.
Pretty straightforward. Haagen-Dazs chocolate. All right.
That's it. Nothing fancy. I don't like my ice cream all full of crap and candy. I pay for ice cream. That's what I want, my ice cream, and I want it thick.
There you go.
You know why I love it? You look at the ingredients. It's like sugar, cream, and cocoa. That's what it's supposed to have. Nothing else.
Nothing else, right?
You pay for it, but it's the best. And then we have Richard's ice cream around here, and then I don't care what you put in front of my face. I'll eat it and enjoy every bite. I don't think there's ever been an ice cream that I ever gave back. Let's put it that way.
There you go. There you go. Oh, where I grew up, there's a place down the road, about a couple towns over, called Kimball's Ice Cream in Massachusetts. Oh, that's just, as we used to say in Minnesota, it's better than sex and almost as good as sweet corn right there. That's living. Kimball's is good stuff, and I said last week, anything with peanut butter in it is just gonna go shoot right to the top of my list of any food. I mean, you can put it in a hamburger, I don't care. It's gonna go right to the top.
You're like me. I love my peanut butter. I mean, I live on that stuff. PB&J's is
and
still at the top of my list.
Say what?
PB&J is still at the top of my list.
Oh, there you go. There you go. Now, do you like the natural peanut butter with that oil at the top that you got to mix up and then it just spills everywhere and it's a pain in the butt? Or do you like, Skippy?
Now, I'm a Jif creamy guy all day long. I like
Jif creamy? Oh, I'm Skippy extra crunchy.
Extra crunch, yes.
I don't know. Maybe that's what I grew up with all the time. That's what my dad liked, the Skippy crunchy stuff.
Yeah, I'm a Skippy crunchy kind of guy.
If I want crunchy peanut butter, I'll throw some peanuts in it. You know, it's peanut butter, not peanut in chunks butter.
Yeah, the blender stopped working halfway through, right?
If you put butter on a piece of bread with chunks all over it, it wouldn't be butter anymore. So I don't know if you can call it peanut
I
butter.
don't even know who you are anymore, Kevin. I think this discussion's over. You're not
Also,
invited
I'm not
back.
afraid to go there, John. I'm not afraid. Although I am afraid to rub elbows with you, to be honest with you.
Let's kind of go there either.
We brought that back.
Hey,
Yeah,
I got to tell you, I've also grown to have an affinity for almond butter.
Oh yeah, absolutely.
Chunky almond butter.
What about apple butter?
Yeah, I've had apple butter. It's all right. It's not the same. You put that on a piece of.
No, that's sweet. Yeah.
Too much. It's not the same.
There you go.
Almond butter, cashew butter, not bad. You know, that's all.
What about Nutella?
I'm Italian, of course, Nutella.
Should have known that.
Come on, man. Of course, Nutella. Of course, you put the Nutella on everything. Come on. Now you want to get fancy Nutella and peanut butter, but you got to put the peanut butter down first and then the Nutella on top. Oh, here's one.
Uh-oh.
You Dave, you can't just go someplace else, Dave. Kevin, you grew up, you have the right accent. You've been here all your life. You know what a fluffernutter is, right?
Absolutely.
Yeah, good cultured, right thinking people know what a fluffernutter is. Have you ever had a grilled fluffernutter?
No.
You grill it like a grilled cheese sandwich. Oh, it'll change your life. It will change your life.
I'm gonna have one tonight.
A grilled fluffernutter.
Can I put it on? Can I put it on scally bread?
You put any bread you want.
There you go.
A grilled fluffernutter. It will change your life. I'm just telling you.
I'm telling you, I'm going for it. Grilled fluffernutter. All right.
Grilled fluffer. Okay, Dave, you can come back now.
I was gonna say, are you trying to say that New Yorkers don't know anything about fluffernutters?
I'm saying New Yorkers don't know anything about anything. All right.
Okay.
You root for the Yankees. What the hell do we have to talk about?
Yeah, we only know pizza here. Yeah.
Well, yeah. No, I'll give you pizza. You do pizza good.
They do pizza good.
In Minnesota, I learned that they would take a round pizza and cut it into squares.
Why?
I don't know. No one ever explained it to me, but that was normal pizza. They'd take big old round pizza and they just cut it into squares.
Did somebody get confused with a Sicilian pizza or something? Or what happened?
It went in a square box. That's all I can think of.
They put a round pizza in a square box. That may have been just too much too
much geometry to cut it into triangles now. Yeah.
Well, that's what happens when you get a Sicilian working in a Greek pizza place. You get round pizzas that are cut in squares. I'm telling you, that's what's happening.
There you go. If Jim Hillpiper's still on the call, Jim, see if you can explain that to us. Why do Minnesotans cut round pizza into square pieces? And every once in a while you get a corner that's kind of like a triangle. It's like 98% crust with a touch of sauce and a little sliver of cheese on it, and that's like that.
That's the last one to go.
That's the last one to go, right? I don't know. It's just it's the way it is. Joe Finelli says a triple decker peanut butter jelly and fluff on baby on toast from Philly. Ooh, peanut butter jelly and fluff, triple decker.
Right. So you got the peanut butter and jelly on one side, and then you throw the fluff on the other, and toast it all in between.
But you do peanut butter and fluff on the other side. So peanut butter jelly, peanut butter and fluff in a triple decker.
Yeah, but you definitely can't cross-contaminate the fluff with the jelly. It just won't be right. That's why you need that separation there. Fluff and jelly just don't go together. Fluff goes with peanut butter, period.
Yeah.
And Nutella, of course.
Yeah, like that grilled. Trust me, grilled. A little bit of butter or mayonnaise on either side of the bread before you grill it, and then the peanut butter and fluff in the middle.
Yep.
And you just cook it like a grilled cheese. I'm telling you, your life will never be the same again.
There's a crepe place down here by me that does that.
Really?
They're making fresh crepes and make them into fluffernutters. Yeah.
Really? Oh, that's kind of cool.
Be cool
Yeah.
too.
You'd be mainlining those before too long, Dave. I'll tell you.
Who knew? My wife's gonna ask me where all the Fluffernutter went.
Anthony Reichow, peanut butter, mayonnaise, and bananas. Peanut butter and bananas. I'm with you.
I think I just
Peanut
threw up in my
butter.
mouth a little.
Now, the mayonnaise, are we grilling? Are we putting the mayonnaise on the outside and then grilling? Is that what we're doing? And Malik says, can we bring a chef next week? maybe we'll get Guy Fieri. You know, that would be all right.
I'll give you one, John. My father-in-law used to put peanut butter on his hot dogs.
That's interesting. I've never thought of peanut butter on hot dogs. I've done them on hamburgers, but I've never seen them on hot dogs.
To put them on hot dogs.
That's different because you need that. You need brine with hot dogs. I mean, you need like a relish piccalilli or relish kind of thing.
Exactly, a relish and some spicy mustard. That's what you're supposed to have. He said when I ran out of mustard, I'd put peanut butter on it when he was a kid. So.
Well, did you ever see him do this, or did he just say he did it?
Well, I'm gonna have to be honest with you. That one was theoretical.
Yeah. Okay. All right. Because I've told I had an uncle who would tell me anything. I mean, he
Right.
He had a finger that went like at a 45-degree angle, and he had 75 different stories on how that happened.
Right.
So.
I think he was probably trying to set me up to have peanut butter on my hot dog, probably.
Yeah. See, Kevin's a little slow. Maybe we can throw this one at him. All right.
Hey, watch this, guys.
Sniffing too much of the chemicals from the analyzers.
Yeah, there you go.
Those wet kits.
All right. I think we're getting out of control here. George
Yeah.
Conrad says peanut butter and raw onion.
Who knew about all these peanut butter recipes?
Yeah, peanut butter and raw onion.
I'm going with the grilled fluffernutter. That's at the top.
Yep.
All right, I'm gonna get rid of this stuff behind me and start setting up a kitchen behind me for next week's
Yeah,
class.
all you gotta do is get a little griddle, like a pancake griddle in the back, and then during the program, you can start grilling up some peanut butter and fluffernutter sandwiches, peanut butter and fluff, grilled fluffernutters. That's change your life. I'm telling you, people. I am telling you, it will change your life. Emerald Holdorf. Mr. McGrath, it's good to see you. How are you? I'm glad you're with us. If George Carlin decided to get into the plumbing, heating, and air conditioning business, he would be Richard McGrath. As Richard McGrath has that same unique and very cutting and very insightful perspective that you just got to respect. I love it. Good to see you, man.
Skills of observation.
Indeed. All righty. Well, I'm actually kind of hungry. I don't know about you guys, but I'm kind of hungry.
Right. I tell you, as soon as I close out this screen, I'm going upstairs and breaking out the bread and peanut butter and fluff.
Make yourself a little sandwich. There we go. Oh, we got Jason Mango. So let's see. Think about this. Hot ham and cheese with mayonnaise. Hot ham and cheese with mayonnaise in the sandwich. I could see that. The cool and the hot and the ham. I could see that. I don't think it'll change my life, but I think I could see that. Can you talk about beer? No, that's tomorrow night, or that's NTI does the beer. NTI does the beer. We don't touch beer. We will talk about different taste sensations, but if you want beer talk, you got to talk you got to hook up with Wheels, Jason Mangos, and Ted Lowe. And Jason, just by way of saying, I think you want to get to Jason early in the presentation, because by the time the presentation's winding down, he's had about 11 beers already, and he starts speaking in tongues. All right, you're not entirely sure where he is or what the heck he's talking about, but get to Jason early. He's got a lot to offer early in the presentation. Later on, man, he's in orbit, and he's not due to splash down for a while yet.
The problem is that Steve's taking the microphone the whole time in the beginning, so yeah.
Well, yeah, there you go. Yeah. All righty, folks. Hey, thank you all. Kevin, awesome job. It's great to hang with you as always. I hope we can do it again sometime.
Pleasure was all mine. All mine.
All
Good to see
righty,
you,
folks.
brother.
We'll
You
see
too.
everybody out there next week. And Dave, we'll talk soon.
Most
And,
definitely, brother.
So long, everybody. Have a
Everybody,
great
good to
week.
see you.
We will see you next week.
Everybody.